So as we said, often things come down to predicting tides, right? Can it be done? Well, of course it can be done, but once we see the real tides, we will see how complicated that may get, right? So idealized tide prediction is going to be very simple, right? You have 2 high tides and 2 low tides per lunar day, and lunar day is 24 hours and 50 minutes. So you have 6 lunar hours between high tides and low tides. Fairly straightforward. Now look at the tidal charts. Remember, if you go to any place like Mumbai or Venice, they have kept tidal charts for sometimes more than a couple of centuries, because as soon as the ship traffic began, trading began, as they came close to the coast, they needed to know the tides. So people on the port always tracked the tides, because if you come into the port at the wrong time of high tide or low tide, you can get into trouble, right? So it's always been very important. In fact, it's very cute to find ports where they have very old tidal charts. You can find those in Venice, for example. I think they're also there in Mumbai, even though I haven't actually looked for them. So let's add our declination to the moon, declination of the moon here of 28.5 degrees. Here our friend Gulab Singh is standing here again in the tidal bulge. So you have 2 tidal bulges because we are still in the idealized tides. We have sunk the land, we have had aquaplanet, and the bottom friction is not going to affect our bulges as they move around with the moon. 6 hours later, Earth is rotating around its axis, so Gulab Singh is going to go out of this bulge behind. So person has moved to the back side of the Earth. We know this person is Gulab Singh. And 6 hours after that, Gulab Singh is going to appear back on this side. Now he is out of the tidal bulge, which is maximum here, right? 6 hours later, he is here in front of us again. So if you track Gulab Singh here from point A to B to C to D, you can see you have he's here in the bulge, so you have higher high tide. If you look at 28 north, where he's standing in the maximum bulge, if you look on the equator, you still have a bulge, but it's not as high as the one in the maximum of the bulge. And if you look at 28 degrees south latitude, there is again a small tidal bulge, right? When Gulab Singh goes to the back, he is now in the negative tide line, negative tide. What does that mean? Basically, you take a long-term average of the tidal movements at any place and you create a datum, a baseline. So since it's a long-term average, sometimes you are below the long-term average and you are above the long-term average. So negative tide just means that the tide has dropped below the long-term datum that is defined for that region, which is shown here as 0. Okay, so positive is when you are above the reference level, and negative is when you are below. So when Gulab Singh comes back on this side 6 hours later in point C, he's in the lower high tide, right? So at 12 hours, you had the higher high tide here. You still are in a high tide, but it's just that Gulab Singh is at a location where the high tide is at its low point. So you have a lower high tide. And then he goes negative again at D, then gets back to A at the higher high tide. This is where the terminology of higher high tide and lower high tide come in, and we will see later on that there is higher high slack water and lower low slack water and so on and so forth. Okay, so just stare at these figures for a little bit to make sure you understand. On the equator, similarly, you have the high tide that is not as high as where the moon is overhead, and the lower low tide is also actually the lower low tide is higher here because, as you can see at point C here, the equator is here. So Globsing is here at the lower high tide, and the equator is here, which has higher levels of tide than where Globsing is. Okay, and you are back to here at A. Okay, so just see how tide levels change based on at what latitude you are and where the moon is overhead. So you have the tides, and then you have where you are, the location where you are. This is what I mentioned as unequal tides. So you have unequal tides. So if you look at 28 degrees south, then you have let's say Globsing went to Australia and he was standing at 28 degrees south. Then you will have this kind of a chart where the higher high tide is now delayed by 12 hours compared to the higher high tide in the northern hemisphere, right? That's out of phase. You're in the opposite hemisphere, moon is over there, so you have a delayed higher high tide. It's very simple stuff. Just stare at it, make sure you understand, and move on. Okay, so I'll stop this here and come back to real tides, because the real tides begin to add complications and things look very unexpectedly different. You will need some terminologies that will be introduced as well. Okay, good.